We are Kickapoo High School. Our project is a geological interpretation of Syrtis Major Plenum. This is our target area. Syrtis Major is located within Arabia Terra and to the west of Syrtis Basin. The image on the left shows the general region of Syrtis Major on the Martian surface. The image on the right shows Syrtis Major itself. The black box that surrounds the region is centered on the coordinates 8.4 degrees north and 69.5 degrees east. Our purpose was to analyze the region and to identify the landforms present, along with the processes that created them. We determined the geological formations and mineralogy of Syrtis Major using morphological and spectroscopic analysis. As a result of this analysis, we made two concrete observations. First, we observed that Syrtis Major appeared to have been greatly influenced by volcanic activity. Secondly, we observed that aeolian processes were also largely present within the region. We used the number of impacts within the region to determine the relative age of Syrtis Major. Since the area around Syrtis Major is so heavily impacted, we hypothesized that it was formed approximately 3.8 billion years ago in the late Noachian era. This was estimated due to the fact that the late heavy bombardment happened 3.8 to 4.1 billion years ago. This was the last time a period of frequent impacts was present in Mars's geologic history. We also hypothesized that Syrtis Major was last active approximately 1.6 billion years ago in the Hesperian era because it overlies the heavily impacted area.
Our first observation is that Syrtis Major is a very large, low-gradient shield volcano. It contains two calderas. Nili Patera is the caldera located northwest, and Muro Patera is the caldera located southeast. Syrtis Major's slopes extend extensively due to low viscosity magma. The magma from Syrtis Major is basaltic in composition and contains very high amounts of pyroxene. It was also found that the region contains low amounts of olivine. Syrtis Major is classified as an albedo feature due to the coloring from its dark basaltic lava flows. This image shows the impact craters in Syrtis Major, specifically the rampart craters. The ejecta from a rampart crater is mostly made up of a mixture of water ice and regolith. However, the craters featured within this region have ejecta that is made up of olivine and pyroxene. The ejecta from these craters were not found to contain hydroxylated silicates, bound water, or water ice. This is an image of a large collapsed lava tube at 12.2 degrees north and 69.7 degrees east. This feature was formed from the erosion of the Syrtis Major volcano, exposing basaltic magma that seeped into the region through a weak area of rock. Lava tubes are significant because they show evidence that lava once flowed through the region. Also, water could have flowed through these hollow channels after the lava had cooled and eroded away. This image depicts a radial dike. It is hypothesized that radial dikes could possibly be hollowed out through interior erosion. When these features become hollow, subsurface water deposits could have the potential to flow through them and migrate towards the poles of the planet. An appropriate time period for this to have occurred is 3.5 billion years ago to 2.9 billion years ago during the Hesperian era.
This chrism tile is located within Nili Patera. It contains very high amounts of olivine and pyroxene. Red indicates olivine, blue indicates high calcium pyroxene, and green indicates low calcium pyroxene. The two chrism tiles are also located within Nili Patera. The image on the left shows the mineralogy of the crater floor, as well as the barcon dunes that are also present there. The image of the caldera rim on the right highlight typical mineralogy data found in this region. The primary minerals in both images are high calcium pyroxene, low calcium pyroxene, and olivine. Red indicates olivine and iron phyllosilicates, blue indicates high calcium pyroxene, and green indicates low calcium pyroxene. Within Syrtis Major, wind streaks are prominent among the impact craters. These dark streaks slightly deflect to the right, corresponding with the Coriolis effect in this region's general location. It is shown that wind streaks bend slightly southwards, indicating that the sediments were blown corresponding to the topography of the volcano. Aeolian processes are prominent within the Syrtis Major region. These images depict Barkhan dunes in Nili Patera. These dunes can gradually migrate with the wind as a result of erosion on the windward side and deposition on the leeward side of the dune. These features contain high concentrations of mafic mineralogy, mainly olivine, high calcium pyroxene, and low calcium pyroxene.
Syrtis Major is an albedo feature due to its great amounts of basaltic lava flows. Radial dikes, collapsed lava tubes, and extensive lava flows are present in Syrtis Major due to a low gradient shield volcano that contained 2 calderas. Wind streaks and Barkhan dunes were very prominent Aeolian features that corresponded with the Coriolis effect and the topography of this region. With spectral analysis, it was determined that this region contained high amounts of olivine and pyroxene, which corresponds with the basaltic lava flows. Lastly, it was determined with relative dating that the last time the shield volcano was active was approximately 2.9 to 3.5 billion years ago, during the Hesperian era. In conclusion, we have observed that Syrtis Major was shaped by impact craters, Aeolian processes, and volcanic activity.
This concludes our presentation of the characterization of Syrtis Major.